All right, guys. This is my third video here, but we're going to tough it out. And also, if you're feeling a bit tired on week 6, it's okay. But keep going. Don't stop, because this is a good use of your time here. All right. So we are talking about triangle congruence. And so when two triangles are congruent to each other, that means there's all their angles. There's a corresponding angle pair, 3 of them, because it's 3 angles in a triangle, right? And all their sides, there's corresponding side pairs for each of the 3 sides. They're all congruent, 6 congruent statements. But there are some shortcuts. So the shortcuts are side, side, side. So these are called triangle congruence theorems. Triangle congruence theorems. Combinations of 3. So if we know all 3 sides, then we know the triangles are congruent. Also side, angle, side. Also angle, angle, side. Angle, side, angle. And I know what you're thinking. Angle, side, side. Well, guess what? It doesn't work. Angle, side, side. I will not write it. But there is one that's called HL. It works for right triangles. And that's the hypotenuse and leg when they're congruent. So side, side, side looks like this. We got 1, we got 2, and then the 3. And then the side angle side is when you got the 1 side pair over there, the angle, and then another side pair. Don't worry, I'm gonna practice a lot of these. I know that this may make no sense yet, but if you're listening, that's good. Angle, angle side means we have an angle, we have a separate angle, and then after the 2 angles, we have a side. Angle, side, angle means we have an angle, and then a side, then another angle. So this side, this angle, they're called the included. They're in between. So let's see. We're looking for the side angle side theorem in these 3 triangles. So as you can see, we have 2 hash marks and 3 hash marks. And here we have only 1 hash mark. So they don't match. This one has 3 and 2. So it's got to be these 2, right? Because they match. And so how are they congruent? Well, let's start with the blank side. So CD. So CD is the blank side of this triangle. And then it would go CD, I guess I would say E, right? And so E is at the top of the 3 side. So then that would mean I would go HI and then J. And that way I have the blank side. And then I go to the top of the 3 side, just like I did over here. You don't want to say IH, and then that wouldn't match. But remember, after we've written our congruent statement, all of the letters should be in matching position. So angle C is congruent to angle H. Angle D, you see angle D here, is congruent to angle I. And so they're both in the middle. And angle E has the hash mark, the arc, and is congruent to angle J, an arc there. So they all match. All right. Okay, so I'm going to give you a proof toolbox, during the weak here. Let's see if we can come up with some really important ones. The one that we're going to use is the reflexive property. Reflexive property says that something is congruent to itself. But you think, why would I need to write that? But it's because sometimes things share a side. So this is like the shared side reason. Okay. Angles can be shared or sides can be shared. And so sometimes in order to get the three statements, sides or angles, we might need to say about the shared side. Also, sometimes things are in the midpoint. So a midpoint, like if I draw a picture of A, M, B, where M is the midpoint of segment AB, then that means that AM is congruent to ME. Definition of midpoint. And then sometimes we might say it's a bisector if we said, so you might also see that it's a bisector and it's going to be the same congruent statement. But if your key word is bisector, then you would just say definition of bisector. All right, so let's see if that might be enough for us to prove this. So when we prove something, we make a table of statements and reasons. All right, this is a logical argument where we will make a statement, we will give a reason, and then we will make another statement that follows, like, yes, I did do my homework last night. I was at the computer, and you can check the history and you can see what I was doing when I was at the computer. And I have my homework right here and I have highlighted it. So in essence, yes, mother, I did my homework. That is a proof that you're giving. Okay, and in geometry, we give proofs. And so the first statement is always what we see given. It could be given in words like it is here, or it could be given in the picture. And we see both, we actually see two pieces of given information. So I'll start with the words Vy bisects angle Wvx. Okay, no, angles can be bisected, yeah, so that is given. The first reason is always the word given. No one ever forgets that. Now, second thing is also given, xv is congruent to wv. Given. Now we got to use the old noodle. What other things do we see? Well, look at my little proof toolbox. Do we see a reflexive item, a side or an angle that is in both triangles? Hopefully you see that Vy is a side in both triangles. So we can make the case that Vy is actually congruent to itself. And we can write the reason is the reflexive property that you just learned. And now we have a side pair in the statement. So I can write that. And we just said another side pair. And now if we can say the angle in the middle, then it wouldn't be angle side side, it would be side angle side. So if I can make the case that these two angles are congruent, then I would have side angle side. is a triangle congruence theorem, which is great. And guess what? Vy bisects this angle. So this Vy is splitting this angle in half. And so yes, XVY is congruent to WVY. And the reason is definition of bisector or angle bisector, which is my other proof toolbox. All right, and guess what? We have just said enough information to say that triangle VXY is congruent to triangle VWY. 5. And the reason is side, angle, side. So we say side, angle, side, triangle, congruence. Wow. All right, so you got a whole IXL assignment to have some fun with and get the hang of this. And then there's the others, the angle, side, angle, the angle, angle, side, right? So angle, side, angle, this means we have two angles and the side in between them, like this. That's angle, side, angle. They're all angle, side, angle. So in this case, we're just looking to see that the hash marks and the arcs match. So I see 1, 1, 1. I see 2, 2, 2. I see, but then look at these. This is kind of easy, right? That's a 1, and these are both 2. So you are out. All right. So you, and now I'm going to use my little strategy, the blank side, and then going to the W. So UV, W. And then I want to go on the blank side up to the top of the blank side, UV, the blank side with the 1 arc angle. So not the QR because that has the 2 arc angle. So it's got to be QP. So QPR. Got it. But IXL will let you know if you're wrong. Don't you worry. All right. So the one more, the most difficult assignment I would say is this next one, K4, because it's the statements and the reasons again. Just write SR. But hey, we know the first reason. What is it? It's given. Okay, and so now here we see these arrows here. What do these arrows mean? They mean parallel lines. And so parallel lines, we know we have the corresponding angle postulate, alternate interior angle theorem, and there's others, but these are the ones that we see in triangle congruence theorems. Yeah, I don't think I've ever seen maybe the same side interior angle here and there, but if you remember the corresponding angle postulate, which is 1 and 2 are congruent, you know, angle 1 is congruent to angle 2 if the lines are parallel, right? And then the alternate interior angle theorem, that's when we have alternate interior, and that would be if the lines are parallel, then you know the alternate interior angles are congruent. Well, guess what? We have alternate interior angles right here. Angle 1 and 2. Angle 1, angle 2 are AIAs. See, so they snuck in. But if you were to draw out these two parallel lines and draw out this transversal, then they're very clearly alternate interior angles. So we won't be too messy, but that's good. Also, is this an alternate interior? No, because we don't know that these two lines are parallel. they look parallel, but in proofs, you cannot use unmarked things if you don't have a reason. And so we can't say that those are parallel just because they look like it. They have to be marked. So like this is marked here. W is congruent to angle Y, and that would be definition of a right angle. So I just gave you another one. Or you could say all right angles are congruent. Maybe we should say that. All right angles are congruent. Ah, do you see the shared side? Oh, no. All right, so let's do this. We can prove it. So, what is our given information? Our given is that x, y is parallel, the two train tracks there, to WV. And so because the lines are parallel, we can say WVX, angle WVX is congruent to angle YXV. So you see that naming angles is very important, and that is the alternate interior angle theorem. All right, so that's one angle pair. Let's do the reflexive. XV is congruent to XV. Reflexive is probably my favorite. So easy. And then it's kind of marked in there. W angle, well, let's just say angle W, angle Y are right angles. That's given, right? Might not always take time to write that one, but then we say W is congruent to Y, and we would say all right angles are congruent. So we're making a little list of things that go from one to the other to prove that these two triangles are congruent. And so we have made an angle statement. These angles are congruent. We said this side pair is congruent, even though it's the same. And we said this angle. And so in my proof, it looks like angle side angle, but actually this angle is right there. This angle is here, and the side is after. So it's actually angle, angle, side. So the triangle VWX is congruent to XYV, looking at the original question. And the reason is angle, angle, side, triangle, congruence. So I want to do a lot of proofs with you this week, and so you'll need to post those in the organizer so we can. The last assignment is kind of a breather here. Can we conclude that these two triangles are congruent? Well, we have a side, we have an angle, and then this shared side, we can say that's congruent to itself, reflexive property. And so, oh, why did I just write an angle? So that would be side, angle, side. So yes, side, angle, side. All right, guys. Work on each assignment for 10 minutes. Watch this video and take notes and post in the organizer. And I'll see you on Tuesday.